Okay, so still in our algebra section. Today we're talking about something called substitution, and we're going to be also looking at evaluating, and we'll define each one of those as we go. But before we do, we had a question from yesterday's work. Remember, the last time we were here, we looked at simplifying brackets, single brackets, right? And we had one that had quite a lot of stuff to do, and it was something like 6x times x plus, wait a minute.
Should we do this one?
Well, it's just an example that someone sent me, but let me find it. Hold on. Okay, so we know that we're doing the brackets first because of the order of operations. We look inside. There was nothing we could do inside. We looked for an exponent, but there wasn't one. But there is a coefficient. The coefficient is 6x. So that means take 6x times everything inside. So 6 times nothing just stays 6. In reality, what number is in front of this 1x, this x here? Since I just said it. It's a 1, right? So 6 times 1 just stays 6. Okay? And what's x times x going to make? X squared, or x to the second, right? Because remember, it's x to the first times x to the first, which means x to the 1 plus 1,
X to the second.
right? Which is x to the second. Excellent. Now, I'm done multiplying with that term, right? So now I need to multiply with this term. And remember, when you're multiplying terms, first thing you do is the sign. We didn't have to worry about the sign on the other one because they were both positive, so who cares? But here I do have to worry about the sign because I have to have something between the two terms, right? You always know where one term stops and the next one begins because you see the sign. So this one is also a positive. So positive times a positive stays a what? Positive. 6 times 3 is 18. And x times nothing just stays what? X. That time the x did not change. Have I done all three of these inside exponent coefficient? Yep. Then the parentheses is done. We're through with it. We've used it up. It's just like you went into the store and spent your money. They don't give you your money back and the thing you buy, right? You've used it. It's gone. Okay? But we still have this 5x that we haven't used yet. So it needs to come down. And it really, if you want to be really careful, you should bring it down when? First, before you start doing any other work. Now, am I done here?
No.
Why not? We can simplify this a little bit because these two terms are called what? Like terms. Now, how come this x is not the same as an x to the second? Because what's different about them? The x? Right, so the x is just a plain old x, but the x squared is an x squared, right? There's a different exponent. So the 6x squared is not going to change, but these two can be combined. So what's positive 18 plus 5 more going to make? What kind though? Positive 23, right? We have to have a plus or minus between them. And then it's going to be 23 what? Just x. Why not x squared? It would be x squared if we were doing what operation? Multiplying. But when you're combining, right? Oranges and oranges make more oranges, not square oranges. Right?
But if you're adding 2, isn't that the same as times 2? Did you got 2?
No, think about it. 2 times 3 is what? 6. 2 plus 2 is 4. Completely different operations. So they behave all totally differently. Right? So if you're combining like terms, then you keep the base and just combine the coefficients.
I don't get it.
Okay, you got to be a little more specific.
I don't get that part where it becomes 18.
Well, because we took our 6 times our 3. And what's 6 times 3?
15.
Yep, and that's where the 18 came from. Mm-hmm.
That was the times?
Right, because it's in front of the parentheses, and anything that's right in front of a parentheses always indicates multiplication. Okay? Now, we'll see some more of these, and we'll practice some more. You've got your Education Perfect out there, so make sure you work on them. If you don't get a question right, then do a similar exercise. Make sure you continue to do it until you do get it. And do not hesitate to email these to me or ask me in class. We'll always do things together, right? But unless you've practiced this, it doesn't make as much sense. All right. So we have to do the bracket first because of the order of operations. In order to do the brackets, we first look where? Inside, guys. Then we look for and then we look for the coefficient, which is the multiplier. And we know it's a multiplier because it's right in front. So, what is the multiplier or coefficient for this particular bracket? Guys? What is the multiplier for this bracket? What is the coefficient or the multiplier for this bracket? 3x. Exactly. It's just whatever's in front is the multiplier. Okay? So don't make it harder than it is. Okay. So what we're going to do today, we're going to move on to, we have a fairly short lesson and fairly easy lesson, but we're going to introduce two critical ideas in algebra. Now, if something is easy, we don't study it. I'm just going to remember that because it's so easy. Ever said that before? And then what happens later? Okay, I don't quite remember what's going on. So.
You want me to ask? That's right.
All right. So, all right. Let's begin our lesson. The first thing we're going to talk about is substitution. What is the root word, do you think, for substitution? Substitute. And you've all heard that word before. We're talking about substitution. So we know that the root word of substitution is to substitute, right? And so what does substitute mean? Anybody? It means to replace something, right? If you have a substitute teacher, that means that you have someone else teaching the class that day, right? So you're replacing something with something else of the same value, that's equal. So, all right? So when you're substituting, it simply means, in algebra, it simply means to replace the variable. What's a variable? The letter. Good. The variable with a given constant. Constant always means a number. Good job. Okay. Well, because I want you to learn. You need to learn the language so that when you see the language, then right.
Why in the first place they don't call it a number?
Well, just life moves on. Okay. All right. So, notice there are a couple of things here. We're replacing the variable. So when I replace the variable, do I have a letter in it anymore? No. It's going to be replaced with something else, right? And also, they have to give you the constant to use, the number to use. Okay? Constant and number are both really interchangeable, but I want to use constant as much as possible so you'll learn the language. Okay? Okay, so anytime you're doing this, though, we have to stay very careful because let's say, for example, we have 2x. And I tell you that I want you to substitute for x with x equals 6. I can't just put a 6 in place of the x and have it mean the same thing. Because there's 2x, if you replace the x with 6, does that make it 26? Absolutely not. Because 2x literally means 2 times x, right? So when you're substituting, you have to keep the values true, right? Whatever operation, whatever rules, whatever your original problem was asking you to do, it still needs to say that, okay? So here's the rule. Never replace a variable with a number. That one was for you. with a number
Thank you.
without using a bracket. Okay? Never replace a variable with anything without using a bracket.
What do you mean by that?
Yep, I'll tell you exactly what I mean by it. Okay? Because we have to keep the operations true. So, let's just go back to that example we had a while ago. Say I have 2x, and I want you to replace the x with the number 6, right? Which part am I replacing? The x. So that's the only part that's going to change. So it's going to become 2 and bracket 6. And now I still know that that means to multiply, right?
We don't have to add the times.
Exactly, because we don't want to put the symbol because we're lazy. Remember where this is algebra. We don't do that. And besides, later you're going to see that you're going to replace things with things that are much bigger. And so the only way to keep the operations true is to use a bracket. Okay? I do not, even though I know you know what this means, I don't want to see that. Because that only applies if you're just having one single number to be replaced, right? We need to think about what's going to happen in the future. So don't do that. Even though it means the same thing, it's one of those little cheats that we use when we're first starting out that comes back to hurt us later, right? Remember when we talked about fractions? Multiply, then simplify. But then later you learn that you can't do that. Instead, you have to simplify, then multiply, right? So it's easier to learn something correctly the first time than it is to fix it later, okay? And what does it mean here to have 2 in front of that bracket? Now that I have a bracket, I need to look inside, okay? So it needs to multiply. So look inside. There's nothing inside. There is no exponent. The coefficient of the bracket is a 2, so that simply means take 2 times 6, which is 12. Okay?
Why
And
does the exponent come before you do the bracket?
because it'll make a difference to your answer when you're finished. Okay? Think about it. Exponents, think about order of operations. Where's exponents? Second, right? So it comes before you do multiplication and division. And so you're maintaining the order of operations.
And brackets and then exponents, like what's in the bracket.
What's in the bracket, then look for an exponent, then the coefficient or multiplier, right? Because multiply and division. So, if you
just because of the math or for some other math?
no, it's just the order of the order of operations will always has to hold true, and you'll look at some and you'll go and then you'll be able to see why. Okay, now, all right. We've just done, and what we've just done is we've done substitution, but we've also done the second part, which is evaluating. This part that we did was evaluating. Okay? So evaluating simply means to simplify after you replace the variable with the given value. And here I use value specifically because it's the root word of evaluate, right? So anytime you see that word evaluate, that means they're going to tell you a number, and you're going to use that number to do the math, right? Because simplify is that word that means do the math, following the order of operations, right?
Sorry, could you explain what value means here?
Value is just a number. Just means some value, right?
Does it have to be a number?
It doesn't have to be. I could tell you to replace it with x plus 2. So it could be any value. Okay? So it's something that you're replacing it with. Good question, though. So later, right now, they're going to be always numbers, right? Because we're just learning. We're just practicing this. But later, when you move on to higher algebra classes, then it could be anything. You could replace it with, something that's 3 feet long. But right now, we're just going to do very simple ones. All right. So let's go to Education Perfect and look at the examples that they give us, and so you can see the wording. Let's walk through this. So in a previous lesson, you learned how to simplify algebraic expressions, and you also learned some definitions about algebra, right? Terms, coefficient, etc. And now we're going to learn about substituting. And again, substituting simply means that you're going to take something and put it in place of something else, right? So, this is why I want to look at this, though, because look at how they give them to you. It's not just 2x here, right? So here's an example. A plumber charges $70 an hour for a call-out fee, and a call-out fee of $40, I'm sorry. We want to set up an equation. This is not an expression, an equation. How do you know the difference between an equation and an expression? An expression doesn't have an equal symbol, but an equation certainly does. That's where the name comes from. Good. So we know it's easy if you'll just assign some variables, assign some values to represent some letters to represent the things that we're doing. So let's use H to represent hours. Make sense? Okay. And we're told that he charges $70 per hour. So that's $70 per hour means $70 times the number of hours he works, right? So that's where they're getting the 70 times H. Do we know how many hours he worked? Nope. Okay, so we're just going to use H. But we're also told that he charges $40 just to come to your house. So, is he going to charge that $40 no matter what?
Yes.
Is he going to charge more than $40 just to come to your house? Nope, it's a fixed fee. In other words, A starts with a C. Constant. There you go. It's a constant. It's going to always stay the same. Good. So the total cost for any job, the cost will equal $70 times H, which stands for the number of hours, plus the $40 that he's always going to charge. So let's say that we call the plumber and he spends 5 hours on the job. So hours equals 5, right? So what we're going to do is simply substitute 5 in place of the H and then simplify it. Do the math. Okay? Now, look at what they did. When they put the 5 in place of the H, what did they put it inside? Bracket. Right? Even though they already had the multiplication symbol, they still use a bracket. So, when is the bracket optional? Never. Okay? Right? Later, as you get better, you'll see that some of them are so small that you could eliminate the bracket, but for most parts and most people, the bracket never becomes optional. Okay, then you just use the order of operations, right? Which says first I have to do that multiplication first. So 70 times 5 gave me $350, plus the $40 ends up costing $390 if this guy comes out for 5 hours. Yes, of course you may. Okay, all right. So that's substituting. You have something, you have some variable, and you simply substitute a value in there. Now that I have that formula or that equation, I could do that for any time he spent, right? What if he came to your house and spent 10 hours? We would simply replace H with what? 10.
Must be replacing the whole time.
Okay. Yeah, that would be a long time. Okay, so you could do it for any of them. What if he came to your house and stayed for half an hour? Simply replace H with 1/2 or 0.5, right? So you can do it for any value. Once you have an equation like this, it's just like having the formula for area of a triangle.
Would you have to put 5H?
No, because remember, you're replacing the H. So there wouldn't be an H left. So if you did that, it would be 70 times 0.5 plus 40. Well, you can't do it if you can't do it if you did that. You have to know the equation before you can replace it, right? So you're going to have the values. Okay. Don't borrow trouble. Okay? Now, the act of doing the math after you substitute something is called evaluating. right? We're plugging in a value and then completing the math. So substitute and evaluate go together, right? It simply means plug in the number they give you and do the math. So if I asked you to evaluate an expression or an equation, that means you just plug in the number they give you and simplify it using the order of operations. So here you see they have 2x minus 1, and they want you to evaluate that where x is equal to what number? 3. So simply substitute 3 everywhere you see an x. Again, making sure that you put it in a bracket. Good. And then do the math. So 2 in front of the 3 there, that means what operation? Multiplication, right? So they multiplied 2 times 3, got the 6. They weren't doing the addition yet, or the subtraction yet, so they just brought it down. And then 6 minus 1 gives us our completed answer of 5. Notice how they wrote this out. This is one problem that I have with Education Perfect. When you're working your problems, you guys are going to do too much in your head. And I really, really want you to get in the habit of writing it out like they did. All right? Don't try to do too much in your head because, remember, right now we're focusing on the process. I know you can do 2 times 3. I'm not worried about that. I'm worried about you making sure that you know how to do the process of substitution and evaluation. Okay? So, write out the steps. Otherwise, you're cheating yourself because later you're not going to know what you did. Right? How did I get that 5? I don't know. I didn't write anything down. Okay? You're only cheating yourself if you do that. Okay. Let's see. Hold on just one moment. Let's see what else they're going to do to us. There's one other section in here that we're going to just look at briefly. And in this section, we're talking about expressions that are equivalent. What do you think the root word for equivalent is? Equal, right. So equivalent, the root word for that is equal. So if 2 things are equivalent, that means they're equal. And the only way they can be equal is if they are identical. Yeah? So 2 expressions are equivalent if they're equal.
Do they have to be unequal?
Exactly, because if they're not, then they can't be equivalent. Okay? So let's look at a couple of examples and see what I mean. So for example, if x equals 1 in one, then that means x has to equal 1 in the other. So the 2 examples they give here are 1 plus x and x plus 1. Are these two expressions equivalent? Yes. It doesn't matter the order in which you add, does it? Now, what if we were subtracting? Yes. 1 minus x and x minus 1, are those equivalent? No. Okay? Right? So be careful. 2 times x and x times 2, are those equivalent? Yes, they both mean x times 2. This one we just don't like because it's not in a simplified form. So sometimes, in order to see if they're equivalent, we might first have to simplify them. Do a little work to clean them up, because we know that x times 2 should really be written as 2x, right? So they're only equivalent if they're identical, but sometimes in order to see if they are identical, we may have to simplify them first. So look, for example, here. Are these 2 expressions equivalent? Well, if you just look at them, do they look equivalent right now? No. Some of you say yes, some of you say no. But what we need to do then is see if we can clean them up. Because if you look, this one has some like terms, doesn't it? So it's not ready to say it's equivalent or not. It's not simplified. So what's 2x's plus another x going to make? 3x, and then minus y. So when you simplify that expression, it becomes 3x minus y, right? Well, look down here. There aren't any more x's, so it's going to stay 3x. But aren't these both y terms? So we can simplify them. Now, remember, that's one of them, right? What is positive 1 minus 2 going to make? negative 1y, which is just the same thing as saying just negative y, right? So don't forget your sign rules. If the signs are different, you keep the sign of the larger number part, right? 2 is more negative. Or if you want to use the number line, remember, if you want to use the number line, you can do that. It says start at positive 1 and then go negative 2 spaces, right? Hopefully you can know the rule, but if you don't, you want to rely on the number line, you can. Okay? Now do they look equivalent? Yes. But they didn't until we first simplified them. Okay? So pay close attention, see if you have any like terms, things that you need to do. So, two expressions are equivalent if they both give the same value no matter what numbers you substitute for the variables, and the only way they can do that is if they're identical. And you must simplify them fully first before you can decide if they are. Besides that, you want everything simplified anyway because you don't want to do more math than you have to, right? Do you want to substitute 20 x terms? No, not when you could combine them all into one first, right? So keep it simple. Okay.